Hello. Yesterday we talked about, we had an introduction on trigonometry. Today we're going to talk a little bit more about coterminal angles that we already mentioned yesterday, and we'll talk more about supplemental and complemental angles. So the first thing that I want you to do, I want you to go on and start the warm-up that you have on your notes. So what you need to do is draw the following angles in standard positions and give the quadrant. So pause the video and then continue. Okay, you should have something that looks a little bit like this. Now what I did, I had 7 pi over 9, so I divided my semicircle, so half of my rotation or revolution. I divided in 9 parts, and I called the 180 degrees, so the straight angle, I called it 9 pi over 9. I divided it in 9 equal parts, and I counted 7 of these. So 7 pi over 9. Notice that I tried to make them as equal as possible, and I did not mark this one because this is between 4 and 5 ninths. So it will be exactly halfway, 4.5 ninths. Also notice that I started my measurement from the positive x-axis. Every angle in standard position should be measured starting from here, from this point, which is 0, or a full revolution. And I proceeded counterclockwise because the positive rotation goes in this direction. So this will be my angle from 0 to 7 pi over 9. And it is in the second quadrant. The next exercise was in 12ths of pi. So what I need to do here, I need to divide my straight angle in 12 pi over 12. Notice that I have, I'm going in the negative direction because I have a negative angle. So starting from here, I go clockwise in this direction, and I have to count 19 of those 12 parts of a straight angle. So I didn't want to put too many numbers because I didn't want it to be confusing. So I started with 12, halfway will be 6, halfway of that will be 3, and between 6 and 12 will be 9. So I can start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So this one will be negative 19 pi over 12. It will be this one. And it's going to be in the first quadrant. Remember, the quadrants are labeled using Roman numerals. They start from the top right, number 1, and then proceed counterclockwise. So 1, 2, 3, and 4. Quadrant 1, quadrant 2, 3, and 4. Okay, so let's talk about the definition of coterminal angles. Coterminal angles are angles that have the same initial and terminal side. By initial side, we mean where I want to start counting. Typically will be the positive x-axis, typically, but not necessarily. And the terminal side is the one where the angle ends. Now, if you notice, angle alpha and angle beta here start at the same point and end at the same point. They are different angles. Beta is much smaller than alpha, but they are coterminal because they have the same initial and terminal side. Likewise, here I have an angle alpha, which is whatever it is, let's say pi over 4, more or less. And then I have another angle beta, which is a full revolution plus another piece. And that is going to give me an angle that is much, much bigger than alpha, but it has the same initial and same terminal side. So to find coterminal angles, given a certain angle, we have to add or subtract 360 degrees if we are in degrees, or 2 pi if we are working in radians. Let's start with an example. Okay, in the first example, we're asked to find the smallest positive and negative angle coterminal to the given one. Now, you see that the first angle is 310 degrees, which is less than 360. So it's already the smallest angle in the first positive rotation. So we're talking about something that looks a little bit like this, probably. Okay, so this will be at 310 degrees. But if I want to find the smallest negative, I can find, let me change color, let's say in red, I'm looking at this angle here, which starts and ends at the same point. So to find the other angle, what I need to do, I will need to do 310 degrees minus 360 degrees, and that will give me an angle of negative 50 degrees. That is the smallest negative coterminal angle to 310. For the second example, we have a negative angle of 800 degrees. Now that's definitely more than 360, so I'm sure that I can find a smaller angle, an angle smaller than 800. So we're starting with a very large negative angle, negative 800 degrees, which is way more than one full revolution. So I have to start adding rather than subtracting. I have to start adding 360 degrees, so a full revolution or a full rotation, until I get to the angle that is the closest to zero. Now, if I add 360, I will still be way over 400, so it's not enough. What I want to do, I want to add at least 360 at least twice. So 360 degrees multiplied by 2. That is going to be 720. So negative 800 plus 720 is going to give me a negative angle of minus 80 degrees. Now, this is the smallest negative coterminal angle possible. If then I want to add to find the smallest positive coterminal angle, I have to do minus 800 degrees plus 3 times the revolution 360. Or if you want, negative 80 plus 360. And that is going to give me 280 degrees positive. Now you try, calculate the negative and positive angle closest to 0 degrees, coterminal to the given ones. So add or subtract as many rotations as you deem necessary. And here are your answers. Now let's try the same exercise with measures in radians rather than in degrees. So what we have now is an angle of 17 pi over 6. And I want to find the closest coterminal angle to 0 positive or negative, the closest positive or negative angle closest to 0. So what I need to do, I need to add or subtract a full revolution or a full rotation in radians. Now we know that a rotation in radians is a total of 2 pi. So I have to add or subtract 2 pi as many times as necessary. Since this one is written in terms of sixths of pi, then I will have to add or subtract 2 pi written as plus or minus, I'm sorry, wrong tool. I will write plus or minus 12 pi over 6, which corresponds to 2 pi. So for the first one, I start subtracting a full revolution, 2 pi, or negative 12, I subtract 12 pi over 6, and that will give me 5 pi over 6, the smallest positive coterminal angle. And if I subtract another full revolution, so another 12 pi over 6, I will get negative 7 pi over 6. Now I repeat the same operation with the other example. This time my revolution should be expressed in terms of quarters of pi. So 8 quarters will be a full revolution. So I'm adding or subtracting, depending on what I want, a full revolution. So if I have a negative pi over 4, I add 2 pi and I get positive 3 pi over 4. This will be the smallest possible positive coterminal angle. On the other hand, minus 5 pi over 4, it's already less than 2 pi, so it's already the smallest negative coterminal angle. I don't have to find another one. Try it yourselves, try practice 2, and then check your answers. So for the first one, I'm adding or subtracting 12 pi over 6. I subtract once and I get 10 pi over 6, which is 5 pi over 3. And that's the smallest possible positive angle. And if I subtract 12 pi one more time, so 22 pi over 6 minus 2 times 12 pi over 6, I will get negative 2 pi over 6, which is negative pi over 3. So for the second one, I have a minus 13 pi over 5. I add or subtract 2 pi, written as 10 pi over 5. And I will get, I add the one first revolution and I get the smallest negative number, so negative 3 pi over 5. And if I add another revolution, I will get positive 7 pi over 5, which is my next, which is my smallest positive coterminal angle. A couple more concepts before we finish this video. First of all, let's recall the definitions of angles based on their size. So acute angles are angles between 0 and 90 degrees. A right angle, which in radians means between 0 and pi over 2. Pi over 2 is 90 degrees. A right angle is exactly 90 degrees, or pi over 2. An obtuse angle is between 90 and 180. Or pi over 2, sorry, between pi over 2 and pi. A straight angle is 180 degrees, which is exactly pi, and a full revolution is exactly 360 degrees, which is 2 pi. The concept of complementary and supplementary angles. Complementary angles are positive angles that are two positive angles that add up to 90 degrees in total. The two angles must be both acute, so in quadrant 1, if we are in standard position. For example, 30 and 60 degrees will give me a total of 90 degrees. Likewise, pi over 6 and pi over 3 added together will give me pi over 2, which is my right angle. Supplementary angles, on the other hand, are positive angles that add up to 180 degrees. So 120 plus 60 gives me 180. Or if you want, 3 pi plus 2/3 of pi, or 2 pi over 3, will give me pi, which is a straight angle. An example. If I have to find the complement of 2 pi over 5, well, the complement is what is missing to get to pi over 2, or 90 degrees. So what I want to do pi over 2 minus the given angle, which is 2 pi over 5, and that will give me the complement. Now notice that the two fractions have a different denominator, so I clearly have to find a common denominator in order to perform the subtraction. So I multiply this side by 5 over 5, and sorry, this and this one by 2 over 2. And that is going to give me 5 pi over 10 minus 4 pi over 10. And I have the complement, sorry, the supplement, or the supplementary angle the complementary angle is going to be 1 over 10 pi, so pi over 10. The supplementary angle, or supplement, is what is missing to get to pi. So pi minus 2 pi over 5 will give me my supplementary angle. I need to do the same thing, so I need to find the common denominator. So I multiply this term by 5 over 5, and I will get that 5 pi over 5 minus 2 pi over 5 is going to give me 3 pi over 5. and that is going to be my supplementary angle. Okay, now let's look at the other example. We're looking for the complement or supplement of 4 pi over 7. Now, if I want to do my subtraction, pi over 2 minus 4 pi over 7, and I transform everything in 14ths of pi, I notice that my angle, 4 pi over 7, is more than a right angle. The right angle is 7 pi over 14, and I'm subtracting 8 pi over 14. So there will be no complement for this one. For the supplement, I will do pi minus 4 pi over 7. Rewrite it as 7 pi over 7 minus 4 pi over 7 will give me 3 pi over 7, which is my supplement, this supplementary angle. Now you try the last practice and then come back to check the answers at the end of the video. And this should be your answers. Pi over 12 for the complement and 7 pi over 12 for the supplement. This is it for today. You can check on your haiku the next steps, and we'll see you tomorrow. Have a good day.